Okay, so we have looked at the notion of parametricizing a curve. So, for example, we've explored something like this, where if you have a circle, x squared plus y squared equals r squared, and we want to represent that circle, that curve, as with a vector valued function, with an x coordinate and a y coordinate of this function, we understand that one way to do that is to assign a parameter, maybe t, and then we can write r cosine t, r sine t, and maybe assign t going from 0 to 2 pi. And that will give us a curve, a circle, that's generated in the counterclockwise direction or orientation. Now, we could have the opposite orientation by making this r sine t, r cosine t. But this is something we've done before. We've parametricized curves like circles. And in general, we might say, well, what about something like this? Well, we could write that as t and t squared, like this. So we're familiar with how to use parameters to represent a curve with a vector valued function. Now notice that we're using t here. So we have t, and that's our only parameter for these curves. Now what we want to do is we want to kind of build on that and look and see, well, what about surfaces? Can we represent a surface with a vector valued function? And the answer is yes, but the way it's going to be just a little more complicated because we don't have just t. What we have is we have a u and a v maybe, or it doesn't have to be u and a v. It can be r and theta, it can be theta and phi, just two different parameters. So what happens is we'll have these parameters, in this case u and v, and you'll have a domain here, and you'll pick u and v values out of here that will generate the x values. The x, well, not just the x, the y, and the z. So for example, what we're going to have is maybe a surface that looks like this. It's r of uv, and over here we would have x, which is a function of u and v, y is a function of u and v, and z is a function of u and v. So there is a vector valued function, and what we've done is this is just the general form of us parameterizing a surface. Now, just to show you how this might work, let's suppose that we have a surface like this. Let's suppose that we have x plus y plus z equals 4, let's say. And I want to write that I want to parametricize that. Okay, so this is a surface, this is a plane. Now, one of the ways we can do this, we can say, okay, here we go. I'm going to do r of uv, and I'm going to assign the x component to be u, the y component to be v, and then for the z, I just solve this one for z. And I have, so z equals 4 minus x minus y. That is 4 minus u minus v. And there we now have a parametric expression for our surface. And we can do surfaces like that. Now, what we want to do is note that there are some surfaces that we see oftentimes, and there are a little bit more elegant ways to represent that surface. So, for example, let's think about a cylinder. All right, here is a cylinder. And what we want to do is represent that with a vector valued function. So now notice that this cylinder has a radius of 3. So let's do this. Let's do r of uv, and just think about each one of these circles. We have a circle here, 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 and here. each one of those circles has a radius of 3. So let's do this. Let's do 3 cosine u, 3 sine u. Okay. And that will give us a circle. Now let's vary the height. So let's put a parameter here that's v. And now notice, when v equals 1, okay, so when v equals 1, here's what we have. We have 3 cosine u, 3 sine u, and 1. So what we do is we get a circle that's up at this height of 1. A circle is formed there. When v equals 2, well, we get 3 cosine u, sine u, and 2. So we get, this circle, and all the way up to 4. So what we can do is we can say, okay, for this right here, I can see that's a cylinder. And, this cylinder in rectangular coordinates would be x squared plus y squared equals 9. So what we're doing is we're parameterizing that. So we're going to have uv 3 cosine u, 3 sine u, and v, and we're going to say, okay, u is going to go from 0 to 2 pi, and v is going to go from 0 to 4 for this particular one. So there we would have a cylinder. Now notice that as v varies, it doesn't change the circle at all. We get the same size circles. Every circle has a radius of 3. So this is a cylinder. So this is one that we need to really take note of. Okay? We need to take note that this is how we model a cylinder. Now, let's think about a cone. A cone is another one that is worthy of consideration. Remember, a cone is something that looks like this. Okay? There's just a basic cone. And we know what that cone looks like. I mean, if we were to sketch it, and I'm just looking at the top part. It looks like this, and it's got it's made up of just a bunch of circles in here. So that if we start down here at 0, we just get a point, and then we get bigger and bigger circles as we go up. So we might say, okay, this is uv, but now the radius is not constant. The radius is changing, and it's changing as the height changes. So we might say, okay, this is v cosine u, v sine u, and then v. So notice, when v is 0, you just get a point. Okay? So when v is 0, you just get a point, 0, 0, 0. Now, when v is 1, you get circles of radius 1. You get 1 cosine u, sine u, and 1. Okay? So you get a circle of radius 1. When v is 2, you get 2 cosine u, 2 sine u, and 2. And so there we get circles of radius 2. But as we go up, we get bigger and bigger circles. So we might say this. We might say, just set v to maybe be between 0 and 5, and u is going to be between 0 and 2 pi. So this is another one that we need to be aware of, and that is the cone. Now, one more that I want to look at that we need to keep in mind, and that is a sphere. Now, in fact, we've got x squared plus y squared plus z squared equals rho squared. Now, we want to be able to parametricize that sphere, and this, of course, is the sphere of radius rho. And to do this, we just need to remember back when we were talking about spherical coordinates. And we were given that with spherical coordinates, we were working with phi and theta. And we said that the x-coordinate was rho sine phi cosine theta. The y-coordinate was rho sine phi sine theta. And then finally the z was rho cosine phi. And this is how we can write a sphere in parametric. This is how we can parametricize a sphere. So this is a sphere of radius rho. So those are the things that we need to keep in mind